In this video, we're going to talk about these push buttons here and get an idea of how they work and how they can be read using an Arduino here so that we can trigger some action to happen when we press them. So a push button is a type of switch. These are sometimes referred to as momentary tactile switches. And what is meant by that is they are only actuated when I am actively pressing down a button, pretty similar to how like a keyboard works, right? You press it and then when you release it, it's no longer working. Unlike a light switch, which will flip on and flip off and stay in that position. This one you have to actively be pressing. So the way that these work is there are essentially two pins kind of on either side here. And right here I have this multimeter set up in continuity mode, which means that when I press these two leads together and they make a connection, it makes that really terrible high-pitched sound. So what we'll see is that if I touch these two pins on the left side or these two pins on the right side, there's no continuity. There's no connection between those 2 points. But if I touch the top two pins, there's connection there. And if I touch the bottom two pins, there's connection there. So what that means is that these two top pins and these two bottom pins are connected to each other internally. So the top two are connected together and the bottom two are connected together, but the top two are not connected to the bottom two. But what happens is when I press this, it should connect the top pins to the bottom pins so that all 4 pins are at that point connected together. So let's see if I can hold this here. If I hold this here and then I press this down, we hear it beep when I press it down. So it's making the connection between that top row and that bottom row. So what we want to do is try to see if we can get this Arduino to read when we have pressed that button there. Alright, so let's get some wires here and try to wire this thing up. So let's think about this here. What we could do is we could connect one row, let's connect like the bottom row to ground here. And then what I could do is I could connect the top row here to, let's just go to pin 2, right? So what we're going to do here is there's essentially 2 states that can happen here, right? It's either pressed or not pressed. And so that sounds like a good candidate for a digital pin here, which also has 2 states. It's either low or high or on or off, basically 0 or 5 volts. So if we think about this here, when I press, it should connect pin 2 to ground. So let's kind of flip over to taking a look at the code, and we might return back to this and see what's going on here in a second. So if I go to my Arduino reference here, there is, under the digital I/O section, there is this thing here called digital read. And what that's going to do is allow us to read some pin, and it will return back some value to us. It will return back whether that value is either high or low. And in order to use a digital pin, if you remember, we have to use the pin mode, which is how we configure whether the digital pin is going to be either like an input or an output. So we say pin mode, we say the pin number, and then we tell it the mode, and it says here there's a few different options, and we'll talk about these here. So let's jump into a new sketch and try to code this up. So the first thing I'm going to do is I'm going to create a macro. I'm going to say pound define, and I'm just going to call it button, and I'm going to say that's connected to pin 2. And what this allows me to do is use that word button throughout the program to refer to pin 2, so that if I ever want to change it to another pin, say 5, I could do that. Or say I had, a bunch of different buttons and lights throughout, I could then just, remember the name as opposed to the specific pin. And then what we need to do inside of setup is configure how we're going to use that pin. So that's when we use pin mode, and then I need to provide the pin, so that is button, and then I need to provide the mode. So let's try input, all uppercase like that, and see if that works for us here. And then the other thing I'm going to do, so this is configuring pin as digital input. The other thing I need to do is set up the serial port. So I'm going to say serial.begin 9600. And what I want to do is just kind of send, whether or not the button is pressed back to the computer so we can, detect whether or not the Arduino is successfully reading that. So inside of loop, remember this is going to run repeatedly over and over and over again. I can use that digital read function, and it just wants a pin, but it returns back some integer value. And the integer value it returns back is basically either low or high. And so low is going to correspond to 0 and high is going to correspond to 1. Those are kind of like our binary representations of those words. So here what I'll say is button. And since this is going to give back some value, I could either store it into some integer variable and just say, okay, let's declare an integer variable, call it reading, and store this value that's either low or high or 0 or 1 inside of here. And then I could print out that information. So I can just put reading right there, and it's going to take that value that we retrieve from the digital pin when we read it, store it in this variable, and then I'm using its value later on to send it back to the computer here. So let's try and upload this and see what we got going on. All right, so done compiling, it's uploading. And now what I'll do is I'm going to hit the serial monitor so we can see the serial port here. But I'm seeing all sorts of zeros and ones happening here, which isn't quite what we want. Let me try to bring both these up at the same time. There we go. So over here, when I press it and hold it, it goes to 0. But when I release it, it seems to kind of fluctuate back and forth between 0 or 1. And what that means is either low or high. Because remember, our digital pins here can only read whether something is on or off, basically whether it's 0 volts corresponding to a 0 over here or 5 volts corresponding to a 1 over here. And so if we think about our circuit here, this ground pin is providing our 0 volts to the bottom row, and then pin 2 is connected up to the top row. So when I press it, it is directly connected to 0 volts, but when I release it, it's not connected to anything. This pin is left floating. That is kind of the technical term for it, meaning that we don't necessarily know its status or what voltage it's tied to. It's floating and it's picking up all sorts of like transient voltage in the circuit. So we need to tie it to some known state here. So like if I pull this out, it's doing the exact same behavior. Like this pin is floating. So if I come over here and I connect it to ground, it's now reading 0, and if I connect it to 5 volts here, it's reading 1. So the code is working as expected, but our circuit's not quite set up properly. So let me plug this back in here. Now you might think, okay, what if we introduce 5 volts into this circuit? Like if I put 5 volts up at the top and 0 volts down at the bottom? But if we think about that, if I press this button, what would happen is it would immediately connect our 5 volts to our ground, which is our 0 volts. And if I directly connect like a higher voltage like 5 volts to 0 volts with no component, no resistance in between it, that means it's going to pull infinite current, and that's a short. That's going to pull a ton of current and cook this part here. So we want to not do that. And so what we're going to talk about is how we can use something called a pull-up resistor. And so I'm going to kind of draw what this looks like here, right? So here is my switch right here. All right, so what I could do is to this top pin here, what I was saying is like if I connected this directly to 5 volts, right? And then I connect this other end here to ground, and then this pin was also connected over here to my Arduino, which I'll just represent with this little box here. This is the Arduino. And that was like my pin 2. If I directly connect it here, what happens is when I press this button, it makes a connection from this point to this point, and 5 volts goes directly down to my ground here, which is 0 volts. So there's a ton of current here, and that's going to cook my Arduino, which is not what I want. But what I could do is at this point right here, I could introduce a resistor. And so what I'll do is I'll introduce something with a fairly high resistance, like a 10 kilo ohm resistor would work. And by putting a resistor there, when I press this button now, there's some resistance in my circuit, so I'm not directly connecting 5 volts to 0 volts, which would pull a bunch of current and short out my Arduino and damage the parts in here. It's going to pull a very, very small amount of current, right? Because our I is equal to our V over R. And so when my voltage is 5 volts and my resistance is 10K, it's going to be very small. But when I didn't have this resistor there, essentially my resistance was basically 0, so it was almost an infinite amount of current being pulled from there. So this is what we want to do. We want to connect a resistor there and tie that up to 5 volts. So that's something called a pull-up resistor, meaning that we're connecting this pin via a resistor and pulling it up to the max voltage, which for our Arduino is 5 volts here. All right, so here is my resistor. And so what that's going to look like here is I still have my orange wire, which is connected to pin 2. And maybe I'll go to like the full screen view here. There we go. So I still have my pin 2 connected to there. But what I'm going to do now is I'm going to put my resistor into that same top row, or the row that the top pin is in. And then I'm going to take this jumper wire and go from where that resistor is, the top part of it, to my 5 volts. And now if I flip back over to here, we can see that it's consistently reading 1. It's not floating anymore. It's not going back and forth between these two different states. It's tied to some known voltage here, which in this case is my 5 volts, so it's giving me 1. All right, and then when I press it, it goes down to 0. So 1, 0, 1, 0. So that's working the way we expect. If I disconnected this 5 volts, it would be left floating again and it goes all around. But if I plug it in, we're in a known state. So that is the basics of how you read a switch. You want to connect it up with an input pull-up resistor, just like this. Now, something that's very nice for us is that inside of this chip, there are actually built-in pull-up resistors that we could use for our inputs like this. You don't have to use like 3 wires and an extra resistor to do that. What we could do is leverage the internal pull-up resistor there. So if I go back to the documentation real quick, if I look at pin mode here, it says that there's 3 modes. There is an input, output, but then there's input pull-up. So I can use this 3rd mode here as a replacement for this circuitry here. So let's kind of change everything back. So I'm going to remove my resistor, I'm going to remove my connection to 5 volts, and leave it how I originally had it. I have my ground here going to the bottom of the switch, and my pin 2 going to the top of the switch. So if I switch back to my code now, and over here, instead of input, if I change this to be input underscore pull up, all caps like that, and then I upload it, we'll see that that was floating right there, so it's toggling between 0 and 1 without me having touched it. But now it should be permanently tied to 1 when it's not pressed, and then 0 when it's pressed. So there we go. That internal input pull-up resistor inside of here is doing that work for us and allowing us to simplify our circuit here, which is awesome. Now, one thing that might be kind of counterintuitive, right, is you might think that when you press it, that would correspond to a 1, and when you release it, that would correspond to a 0. It's not quite that, so you might have to kind of logically flip that in your head. But aside from that, that is kind of the core basics of how you can read a switch. So in the next video, what we'll do is we'll talk about how we can make decisions in our code based on whether or not this switch is pressed.